Hello everyone, my name is Murutura Enoch and we are going to revise together PH 110, the question under dynamics. So the question reads, a block of mass M on a rough inclined surface is acted upon by a force F at an angle with the inclined as shown below. The surface is inclined at an angle and the coefficient of friction, kinetic friction between the block and the surface is mu k. So that is just the simple diagram that is illustrating the question. So the first question, they are saying draw the free body diagram of the object. So what you should know is that whenever you are drawing, bear in mind that the force was being acted going upward. Now that force can be resolved in y-axis and x-axis. So what you should bear in mind is that when you resolve that force in x-axis, since there is an angle cutting that force, meaning it should be F cos theta. And then if you resolve it in y-axis, meaning another force should act upward, which is F sin theta. Now apart from that, there is the gravitational energy which acts downward from the center of an object, which is mg. And then also from there is another force opposing this force of gravity, which is norm. It acts what? Upward. It's supposed to be n. And then from there we have another force, which is mg cos theta. And then another force opposing that force, which is mg sin theta. Now from there is kinetic friction force. So friction force, that is any force opposing the motion. Since the motion was going this side, so it is supposed to be there, which is Fk, symbolizing what? Kinetic friction. So that is the free diagram. So we proceed to question 2, where they are saying show that the acceleration of the block is that. So from there what you should bear in mind is that we have first to obey second Newton laws. So we are going to add all the forces acting upward with to be equated with the mg cos theta. So summation of those forces acting upward should be equal to mg cos theta. So supposed to be normal force plus, the reason why I've put plus because they are going in the same direction. So from there we put also F sin theta is equals to what? Mg mg cos theta. Or in short, I was doing that is summation of normal force plus F sin theta. You subtract the force that is acting against minus mg cos theta should be equated to what? To 0. Now if you take that mg cos theta to the other side to become positive like that. Now from that step, what you are supposed to do is that make n the subject of the formula. So n is equals to mg cos theta. That one is positive f sine theta, so when it crosses the equal sign to become a negative f sine theta. So now one thing that you should bear in mind is that kinetic friction is equals to mu k times what? Normal times normal. So from there what we are going to do is that we are now going to add the forces acting in the x-axis. So it's summation of f forces acting in x-axis should be equated to what? Ma, abiding to the second Newton's law of motion. So from there, since the force was acting upward there in the x-axis, so I'm going to write f cos theta. Now these two forces that are acting against should be subtracted, so minus fk minus what? Mg sine theta, which should be equal to what? Ma. And then from there we have f cos theta minus what is the friction, kinetic friction. So we have to find, we are going to follow that mu k. So mu k, open brackets, the normal we have calculated there, which is mg cos theta minus f sine theta, that is fk, and then minus mg sine theta is equals to what? Ma. So from there we are going to rewrite, that is f cos theta minus, so that mu k should be multiplied with everything in the brackets. So when you multiply mu times mg cos theta, you are going to obtain mu k mg cos theta minus negative mu k times negative, that to be positive mu k f sine theta minus mg sine theta is equals to ma. Now we want to make the subject of the formula, so we are going to divide both sides by m, also that side by m. So there is going to cancel. You are going to remain with a is equals to f cos theta minus mu k mg cos theta plus mu k f sine theta minus mg sin theta divided by what? By mass, which is m. Now from there what you are going to do is that you are going to correct the what? The like terms. So that is f cos theta plus mu k f sine theta minus mu k mg cos theta minus mg sin theta divided by what? Mass. So acceleration is equals to what? So what you are going to do there, you are going to factorize what is common, and what is common is f. So f, so if you factorize there, you are going to remain with what? Cos theta plus mu k. So from there you are going to remain with the sine theta. You close the bracket, and then what is common there, you are having a negative mg, so you are going to remain with the mu k cos theta. There you are going to put plus, so that when you multiply that negative with that, it's going to bring you back to that thing. So that is sine theta. So divided everything by what? By m. So therefore hence shown. So this is our final answer. These are the solutions that were supposed to be there at that question that we are revising. So if you compare the answer with the one that is in the question, they are just the same. So you can see they are just the same, so hence shown. So please don't forget to like this video and subscribe, so that whenever I post the new video, you are able to see you in the next video.